Today we'll study about the gaseous state. That means what do you mean by gaseous state and what are the laws that are involved in gaseous state. This is Anupam Sahu, Associate Professor and HOD, Department of Pharmaceutics, School of Pharmacy, Rai University. So first is what do you mean by gas law? So gas law there is pressure, volume, temperature, and amount of substance. These are the variables which specify the purity of the gas or state of pure gas. Once again, I'm saying. What do you mean by gas law? Gas law means it includes pressure, volume, temperature, and amount of substance or number of moles. These are the variables which specify the state of pure gas. Okay. Certain certain gas law were introduced depending upon the gas behaviors such as Charles law, Gay-Lussac law, Boyle's law, and Avogadros law. We'll discuss one by one in next slide onwards. I have started. I have developed one formula that is to recognize all these gas laws. That is, PVT. PVT means private. Private limited. We are saying na. That is, you have to remember only PVT. That part. That is private limited. Okay. So these are all the variables of gas. These are the constant. Means you have pressure is constant. Where pressure is constant, that is called Charles law, and variables is volume and temperature. Okay. In next, V is constant here. In Gay-Lussac law, volume is constant. So variables are pressure and temperature. Next is Boyle's law. In Boyle's law, temperature is constant and variables are volume and pressure. Next is Avogadro law. In Avogadro law, pressure and temperature are constant and volume is directly proportional to number of moles of the gas. So these are the variables and these are the constant. Charles law. As per our formula, I have told you that PVT. In Charles law, P is constant and volume and T are variables. So volume is directly proportional to temperature. So simply we can say that Charles law states that at constant pressure means pressure is constant here, volume is directly proportional to temperature. Okay. So mathematically V1 upon T1 is equal to V2 upon T2. Gay-Lussac law. As you know, in Gay-Lussac law, that is volume is constant. So pressure and temperature are variables. So you can say pressure is directly proportional to temperature. So in Gay-Lussac law, that states that at constant volume, pressure is directly proportional to temperature. Pressure is directly proportional to temperature. So mathematically, if you calculate, then pressure upon temperature means P1 upon T1 is equal to P2 upon T2. Next is Boyle's law. In Boyle's law, temperature is constant here and pressure and volume both are variables. So we can state that Boyle's law states that at constant temperature, pressure is inversely proportional to volume. Remember here, pressure is inversely proportional to volume. That means if you calculate mathematically, P1 into V1 is equal to P2 into V2. Next is Avogadro's law. In Avogadro's law, pressure and temperature both are constant here and volume and number of moles, these two are variables. So what Avogadro's law say that? Avogadro's law states that at constant pressure and temperature, means pressure and temperature are constant over here, and the amount of gas in moles that is directly proportional to volume of the gas. That means the number of moles of gas is directly proportional to volume. So we can say mathematically V1 upon N1 is equal to V2 upon N2. For equal volumes of two gases at fixed temperature and pressure, number of moles or molecules are equal. Next is ideal gas law. Ideal gas law is expressed as equal volume of gases at same temperature and pressure contains the same number of molecules. If we will take equal volume of gases at constant temperature and pressure, then the number of molecules of the gas is same. So mathematically it is expressed as PV is equal to nRT, where P is equal to pressure, V is volume, N is the number of moles, R is the ideal gas constant, that is called ideal gas constant, and T is the temperature. Next is Dalton's law. In Dalton's law, if I'll give one example, if I'll take 2 or 3 number of gases in a container, the sum of the individual partial pressure is the total pressure in that gas. Understood that one? Means if we'll take the 3 number of gases, then the individual partial pressure, the sum of individual partial pressure is equal to the total pressure of the container. Then mathematically P is equal to P partial pressure of gas A, partial pressure of gas B, partial pressure of gas C, and partial pressure of whatever the number of gases in that container. The partial pressure, the sum of the partial pressure is the total pressure of the gas. This relation fits for all real and perfect gases. Thank you very much.